Welcome back to the deep dive. Our mission here is, well, it's to take these complex, massive piles of research, all the articles, the global analyses, the technical frameworks, and really distill it all down.
Right, into the core nuggets of insight you need to understand the world around you efficiently, thoroughly.
And today, we are talking about an industry so fundamental, so just colossal, that its failures, they impact every single person on the planet.
It's a critical investigation into the global construction sector, and we're not talking about small numbers here.
No, not at all.
We're talking about an industry that currently accounts for roughly $10 trillion.
10 trillion annually.
Annual, yes.
Yeah.
Spent on related goods and services. And that figure is only going up. It's projected to hit $14 trillion by 2025. I mean, it is the engine that builds our cities, our infrastructure, our homes.
Yet, and this is the core of our deep dive today, despite this monumental scale, construction is simultaneously defined by chronic underperformance. This is an investigation into why this massive global industry is, just chronically lagging in productivity.
And what systemic failures define its performance.
Exactly. And crucially, what structured management frameworks have been proposed to finally close this monumental gap.
That gap is quantifiable, and the number is. It's just staggering.
Yeah.
$1.6 trillion.
Okay, stop there. 1.6 trillion.
That is the value added the world is missing out on every single year.
Mm-hmm.
All due to construction stagnation.
So let's put that number into the context you, the learner, need to grasp. If construction labor productivity simply caught up to the total growth rate of the global economy.
Which isn't even asking for it to lead, just to keep pace.
Right, just catch up. That added value, that 1.6 trillion, could cover half of the world's total annual infrastructure investment needs.
Half. Think about that. Schools, hospitals, resilient roads across the globe, all from closing one industry's productivity gap.
Or, to look at it another way, it would boost global GDP by a full 2%. The potential for societal and economic transformation it's just immense.
So the stakes are not just about corporate profits. I mean, they are about global prosperity and our ability to meet the growing demands for housing and, resilient infrastructure.
Okay, so let's unpack this. If the upside is so transformative, what exactly is holding back this critical sector? Why is an industry that spends $10 trillion a year performing so poorly?
That's the key question.
We have to start with the cold, hard data on stagnation in Section 1.
The hard data on stagnation is, well, it's a painful read. When you look at labor productivity growth in the construction sector globally, it has averaged a pitiful 1%.
1%.
1% per year over the past 2 decades. That is almost a definition of standing still in a dynamic global economy.
1% per year. To visualize that, imagine trying to sprint while shackled to a lead weight.
That's a great way to put it.
And that comparison becomes even more striking when you look at its industry peers, right?
It does. Over that same 2-decade period, the total world economy grew its productivity by 2.8% per year.
Okay, so nearly 3 times faster.
In manufacturing, the sector construction is always contrasted against.
Of course.
Grew at an average of 3.6% per year. So this isn't a temporary dip. It's a decades-long systemic failure where construction has just consistently failed to adopt the efficiencies that transform nearly every other major industry.
And here's where it gets really, really interesting, especially in terms of historical context. The sources dive back to 1945.
The post-World War II era.
Exactly. And they track growth across key sectors. And just think for a second about how much manufacturing, retail, and agriculture have changed since then.
Oh, fundamentally. The introduction of automation, massive scale standardization, digital integration.
The figures are just astonishing. Since 1945, productivity in those sectors, manufacturing, retail, agriculture, grew by up to an incredible 1,500%.
1,500%. It's a radical, explosive efficiency gain.
Yeah.
It completely changed how goods and services are delivered.
And so what about construction during that same, 80-year window?
Construction productivity has barely increased at all.
Barely at all.
We're talking about an industry that, in terms of labor efficiency, is still operating in a very similar way to how it did 8 decades ago. This flatlining is the historical failure that underpins the entire current crisis.
That really puts the magnitude of the problem into perspective. We keep hearing about labor shortages and rising costs, and this lack of productivity growth is the primary driver.
It is.
Which brings us back to that monumental figure, the $1.6 trillion opportunity.
And this is the critical takeaway for you, the listener. The $1.6 trillion is not theoretical. It's the estimated annual increase in value added, the economic output, if construction simply managed to close this massive historical productivity gap.
So it's the direct annual cost of stagnation.
Yes, a cost borne by every consumer, every government, and every company requiring new infrastructure.
If you just imagine that figure reinvested globally, I mean, think of the accelerated development of sustainable building technologies or the rapid deployment of necessary power grids.
Or the housing crises that could be significantly alleviated.
The stagnation has profound humanitarian and economic costs.
And what's particularly telling is how ubiquitous this problem is. The analysis of construction firms globally showed that over the past decade, less than 25% of them,
Just a quarter.
less than a quarter, managed to match the productivity growth achieved in their own overall national economies.
So it's not a localized issue. It's not a problem with a few outlier companies.
No.
It's a fundamental institutional failure of the entire sector to keep pace with modern economic dynamics and efficiency standards.
We have an industry that is vital, yet deeply resistant to innovation and scale.
Which tells us we need to look beyond just the numbers and really examine the inherent structure and the culture itself. Let's transition into section 2 and examine the characterization of this poor performance. The systemic issues defined by this dual dissatisfaction of both clients and the workforce.
The poor performance of the construction sector, it really creates a toxic environment, and it starts with the industry's own financial instability. It is characterized by low and, crucially, unreliable profitability. When your margins are thin and unpredictable, it just creates this cascade of negative effects.
And this low profitability directly contributes to the high rate of business failure, right? Particularly among the small to medium enterprises, the SMEs, which really form the fragmented base of the whole sector.
That's it. If you're constantly fighting for survival on razor-thin margins, where is the money for the future going to come from?
There isn't any.
Exactly. The most crippling side effect is the lack of investment in research and development, in R&D.
Right. Manufacturing invests heavily in R&D to drive that 3.6% growth we talked about.
But construction firms, they're trapped by volatility and low margins. You simply cannot afford to innovate or adopt new, riskier technologies.
And this low performance, this financial instability, it just feeds a vicious cycle that solidifies the industry's bad reputation. The sources highlight that the sector is often seen as fragmented, riddled with disputes, and sometimes defined by cowboy, meaning unreliable builders.
That reputation has a profound impact on human capital. I mean, when you are competing for the top graduates in engineering, project management, technology, how do you attract them?
Yeah, good question.
Why would a highly ambitious, tech-savvy student choose a career in a sector perceived as adversarial, financially volatile, and technologically lagging, when they could pursue stable, high-paying careers in law, or medicine, or advanced manufacturing?
The competition for talent is extremely high.
And construction is losing badly.
Okay, so that covers the internal struggle. But the dissatisfaction is equally strong from the outside the client experience. When clients commission projects, what are they routinely facing?
They face poor quality of construction. That leads inevitably to constant repairs and reworks.
The worst.
They encounter chronic inefficiency in getting timely responses to complaints or requests for design changes. And they express this deep lament over the systemic lack of innovation coming from both contractors and designers. The industry is effectively failing to deliver on the fundamental promise of value.
It sounds like a total breakdown of trust. You're talking about massive multi-million or even multi-billion-dollar expenditures that routinely result in disputes, claims, and something that makes long-term asset management a total nightmare, incomplete as-built drawings.
Right. The people who eventually operate the building decades later often don't have an accurate record of how it was truly constructed.
So that's the external consequence. Now let's pivot to the other side. The supply team dissatisfaction. Let's talk about the workers and the inherent process flaws.
On the human capital side, the working environment is brutally demanding. The sources consistently cite reports, like the famous Egan's report, which states that construction has the second worst health and safety record of any industry.
The second worst. That single statistic just puts the human cost of this stagnation into terrifying perspective.
It's compounded by the terrible working conditions inherent in site-based work. You have exposure to harsh weather, often substandard or temporary site facilities, and poor job security because employment is project-based and temporary.
It's a tough gig.
Precisely. The data on the workforce demographics points to a completely unsustainable trajectory. Construction workers are getting older. They consistently work longer hours than employees in most other industries.
And they're statistically far more likely to be involved in an accident.
They are.
And what is the reward for all this elevated risk? The long hours, the physically demanding labor.
They are, on average, only paid around the median for all industries,
So it's a low-margin, high-risk sector for the workers themselves.
which further exacerbates the inability to attract new, young talent. It's a feedback loop.
And beyond the human element, the core problems are deeply structural and cultural, which makes change incredibly difficult.
And the most fundamental flaw is the separation of design and construction.
This siloed approach, I've heard it called the original sin of the industry. You have architects and engineers working in one phase, creating blueprints, and then completely separately, contractors take those blueprints and try to execute them. What's the consequence of that separation?
Huge inefficiencies. Designs are often technically feasible, but financially or logistically inefficient to build. They're not optimized for constructability.
Right.
This separation causes longer overall durations and inevitably fosters an adversarial, tension-filled culture when the designers and builders finally have to interact and inevitably blame each other for any issues.
And when the architect is the undisputed project leader, the focus often shifts overwhelmingly toward design aesthetics and vision rather than the core metrics that define true client value: cost, time, and quality of service delivery.
Our source material points out this is often compounded by the fact that the design leadership may have limited formal project management skills.
Then you have the procurement system itself, what the sources call the competitive tendering trap.
Right. Because the standard procurement method focuses almost exclusively on seeking the lowest initial cost rather than overall long-term value. It just starves the industry.
And if everyone is forced to bid as low as possible just to win the job, they operate on these razor-thin margins. That actively stifles innovation. I mean, who can afford to try a new, better process if failure means bankruptcy?
It forces contractors to absorb high tendering costs for bids they likely won't even win, and it leads to the frequent discontinuity of project teams.
A new team for every project.
Every project, new team, a new set of relationships, which means no institutional learning or long-term process improvement occurs across the entire sector.
And this resistance to standardization is deeply rooted in the dominance of the old craft culture. Construction remains overwhelmingly site-based, relying heavily on manual labor and traditional trades performing work exposed to the elements.
This reliance on traditional craft methods, rather than industrialized processes, means a high sensitivity to weather, limited standardization across different projects, and poor quality control that is highly dependent on the skill level of temporary site workers.
It resists technology. It resists modern production methods.
And contributes directly to those high costs and long durations we discussed in Section 1.
We see the effects of this fragmentation everywhere. Projects are delivered by temporary teams using specialist subcontractors, forming these incredibly long and complex supply chains that are a nightmare to manage and coordinate.
Every new building is essentially a unique prototype built in unique conditions.
What's truly insightful here, and what you, the learner, must internalize, is the fundamental flaw in the industry's accountability and its learning feedback loop.
The source material notes that project team responsibility ends abruptly at the completion of construction.
They hand over the keys and walk away.
That is the central irony. The teams are focused on getting to the finish line, not on the ultimate performance of the asset. This means that life cycle costing, the true financial burden and operational efficiency of owning and operating a building over decades, is generally not factored into the design or build phases.
So they get no performance feedback.
None. The design teams don't know if their brilliant aesthetic choices led to huge energy costs or impossible maintenance headaches 10 years down the road. The link between design, construction, and long-term user value is completely severed.
So they price the product before they produce it, which locks in all this financial risk. And success isn't judged by maximizing value delivered to the end user.
No, it's judged by whether they manage to keep the cost to the initial, often artificially low, estimate. The entire system is structurally incentivized to reward low initial cost, even if that decision leads to massive, long-term operational costs, high rework rates, and pervasive client dissatisfaction.
And this structural incentive system explains exactly why we see those truly catastrophic failure metrics that define the industry. Let's dive into those hard numbers in Section 3.
If Section 2 provided the structural reasons for failure, the culture, the fragmentation, the adversarial contracts, then Section 3 presents the shocking, quantifiable consequences of that structure. Let's start with cost overrun. The financial collapse of project budgeting. Across the industry, the aggregate cost overrun is a staggering 76%.
76%.
76% compared to the initial contract prices.
So that means when you sign a contract for a, let's say, $100 million project, you should realistically expect to pay $176 million.
That's right.
That's not a simple margin of error. That represents systemic financial mismanagement and a deep crisis of confidence for clients and investors.
It is. And the analysis clearly attributes this massive financial delta to predictable recurring failures, which are just symptoms of the underlying structural flaws.
What are the primary reasons they cite?
They fall into several key buckets:
Okay.
incomplete designs, subsequent design changes, scope changes, and quantity changes. All of these point right back to insufficient investment in the initial planning phase and that adversarial relationship between designers, clients, and contractors.
But it's not just design instability, is it?
No. The sources also highlight operational and economic factors, too, such as the contractor's poor capacity, their inability to scale or manage the complexity of the project.
Okay.
We also see external economic pressures, like rising inflation and price hikes during the long duration of the project, which contractors struggle to manage or hedge against.
And you can't forget the external, sometimes unpredictable variables.
Like force majeure events or, critically, employer inactions, such as delays in providing necessary information, slow approval processes, or land acquisition issues. It's a highly volatile mix where the cost just spirals quickly out of control.
And that volatility translates directly into project delays, which we quantify as time overruns. Here, the sources provide detailed metrics broken down by subsector.
Right, highlighting where the failure is most acute.
And the numbers are.
The time overrun metrics are even more dramatic than the cost figures, especially in the more complex, bespoke areas. The maximum time overrun is found in the building sector, reaching an alarming 160.7%.
Hold on. 160%. So if I was promised a new office tower in 12 months, I'm waiting for 2.5 years.
Roughly, yes. And the implication is enormous. Beyond penalty costs, those delays can ruin a city's traffic management plan, stall commercial tenants, or cause critical social infrastructure, like hospitals or schools, to be unavailable when they're needed. The project intended for 1 year takes 30 months. It profoundly disrupts municipal planning and economic activity.
And how do other sectors compare to that?
The water subsector, dealing with complex, bespoke infrastructure projects, follows closely behind, with nearly 150% overrun.
Still huge.
Still huge. Interestingly, the road subsector, which involves more standardized, repeatable processes, fares the best, though it's still struggling with a minimum time overrun of 63.34%.
Which strongly suggests that complex, unique construction projects suffer most from the industry's lack of standardization and planning failures.
Exactly. The core reasons for time overruns almost perfectly mirror the cost issues: design changes, scope changes, contractors' low capacity, incomplete design.
But the sources also highlight unique, time-specific factors.
They do, such as adverse weather conditions, which again underscores the inherent vulnerability of the site-based craft culture. Poor initial estimation of completion time, and bureaucratic or legal delays related to land acquisition issues.
Finally, we have to examine the Achilles heel of the industry: quality management.
Right. Quality is subjective unless it's rigorously measured, often through recording defects and issues in a project quality register. The data on quality practice maturity levels it's damning.
How low are we talking?
The analysis reveals that 10% of contract implementers perform little to no quality management practices at all.
None.
They are effectively operating on faith and traditional methods. Compounding this, another 32% are judged to be at an incomplete practice maturity level.
So roughly half the industry, 42%, is operating below basic quality standards.
That's the takeaway.
This is the direct feeder to the poor client satisfaction, the constant reworks, and that 76% cost overrun we identified. If you don't manage quality up front, you pay for it exponentially later.
It confirms that the industry needs to stop treating performance as some abstract goal and move toward rigorous, structured management frameworks that have been used successfully in other complex sectors.
And that shift in mindset from a craft-based reaction to process-based control requires defining the tools of the trade. That brings us to Section 4, establishing the Performance Management Toolkit. When you're attempting to fix an industry so plagued by inconsistency, The first step is always linguistic clarity.
Absolutely.
We need to distinguish between terms that are often misused interchangeably, like performance and productivity.
Let's start with productivity. This is the narrow, purely operational ratio, output divided by input.
Simple math.
It is. It's the quantitative measure of operational efficiency. For a construction example, it's the number of cubic meters of concrete placed per person hour, or the number of bricks laid per shift. It measures the physical efficiency of a defined task.
Okay, so that's useful for micro-level operations. But performance is the strategic big picture. How do we define that more broadly?
Performance is a much broader, more holistic concept. It certainly includes productivity, but it crucially expands to encompass profitability and a whole host of non-cost factors that truly determine project success and organizational health.
Such as?
Non-cost factors like quality, so how well the asset functions; speed, which is time to market or completion; delivery, meeting promised specifications; and flexibility, the organization's ability to adapt to changes.
So performance is ultimately about how well the organization achieves its set strategic goals.
Which almost always go beyond mere physical efficiency.
That distinction naturally leads us to the two E's of performance management, which we often mix up in daily language: efficiency and effectiveness.
Yes. Efficiency is the internal measure.
Right.
It asks, are we doing things right? It compares the actual amount of resources used, labor, material, time, to the minimum level theoretically required to complete the task.
Okay.
A team might be efficient if they lay the required number of square feet of flooring using minimal material waste.
And effectiveness is the external goal-oriented measure. It determines if the effort actually contributes to the overarching objective.
Correct. Effectiveness measures the actual output in relation to the expected output and asks, are we doing the right things? An organization is effective if the bridge it built not only came in on time, but also successfully handles the traffic volume it was intended for.
Right. You can be highly efficient laying concrete quickly, but completely ineffective if the concrete mix is wrong and the structure fails.
Exactly. Understanding that hierarchy, that effectiveness trumps efficiency, is crucial for strategic alignment. And the sources define performance management not as a one-time metric, but as a continuous process.
A process essential for organizational health.
It is continuous, and it is a communication tool designed to bridge the gap between supervisors and subordinates, ensuring everyone is aligned and driving toward continuous improvement.
And this continuous performance management process breaks down into 4 sequential phases. It starts with planning.
Planning is about defining the roadmap. It involves setting clear objectives for the project and the team, defining development plans for personnel, establishing key performance areas KPAs that align with strategic goals.
And, critically, establishing the objective standards for evaluation and the necessary frequency of feedback sessions.
You can't assess performance if you haven't defined what success looks like first.
The next phase is maintaining. This is the execution phase.
This is the ongoing, real-time work. It involves the constant monitoring of performance against those standards, providing coaching and mentorship where needed, giving constructive feedback, and ensuring regular informal interactions between management and teams. It's about making minor course corrections daily, not waiting until the end.
Then we have reviewing, the formal moment of truth.
Reviewing is the structured assessment. Formal reviews take place. Performance is rigorously assessed against the objectives and standards set during planning, and periodic reports are generated.
This phase identifies both strengths and weaknesses.
Strengths which can be replicated, and weaknesses which require immediate corrective action.
And finally, the loop is closed with rewarding. If we don't reward measured improvement, the entire system just collapses.
This step ensures sustainability and buy-in. It requires transparently linking pay, bonuses, incentives, and promotions directly to the performance results. If workers see a direct, positive connection between adopting new, more effective practices and their financial or career success, the process gains the power to truly drive cultural and operational change.
That structural framework provides the discipline the industry desperately needs to escape its craft mentality. But structure is useless without accurate data. To execute this, you need reliable measurement tools.
You do.
Let's look at the sophisticated systems for insight in Section 5. The fundamental concept here is universal. If you do not measure performance, you cannot possibly have a basis to plan or sustain improvement.
That's absolutely right.
Measurement is the necessary antidote to institutional complacency.
And the primary benefit of measurement in this industry is that it reveals problems that bias, emotion, and long-standing cultural assumptions have covered up.
Mm.
When you've done a task the same inefficient way for decades, you just assume that's the only way. Metrics ensure decisions about resource allocation and process modification are fact-based.
Which leads to much more effective utilization of those scarce resources.
Exactly.
So we move past simple spreadsheets and look at sophisticated models designed to quantify performance beyond just the financial bottom line. First, the incredibly successful framework known as the Balanced Scorecard, or BSC.
The balanced scorecard is powerful because it forces organizational leaders to look at their health holistically. It measures performance through four main categories, ensuring that short-term financial gains don't destroy long-term strategic viability.
We start with the obvious one, the financial perspective.
These are the standard measures: revenue, operating profit, return on capital employed, cash flow, all of that. They tell us if the company is generating short-term returns. But the BSC immediately balances that with the internal business process perspective.
Okay, so this perspective looks inward. It asks how well the company operates day to day.
Right. Metrics here would include things like defect rates, cycle time for key processes, and the efficiency of project execution, the operational health of the firm.
And crucially, the BSC includes the customer perspective.
The external view, it asks, are our customers happy?
A simple but often overlooked question.
It is. Metrics would be things like client retention rates, satisfaction scores, percentage of rework requests, and market share achieved. This perspective fights the tendency to deliver projects that meet the contract but fail to meet the actual user needs.
And finally, the key recent contribution to the BSC framework, the innovation, learning, and growth perspective.
This is the future health perspective. It looks at the organization's ability to evolve and sustain itself.
So what are we measuring here?
Metrics here would include employee training hours, knowledge management capabilities, the percentage of revenue derived from new services or technologies, and R&D spending. If this perspective is neglected, the company might be profitable today.
But it will certainly be obsolete tomorrow. By using these four perspectives simultaneously, the BSC prevents a company from focusing entirely on cutting costs at the expense of investing in new technologies or ignoring client complaints.
It forces leaders to manage those strategic trade-offs effectively.
And an alternative model, developed specifically due to dissatisfaction with purely financial measures, is the performance pyramid.
Also known as the SMART system. This model provides an elegant way to link shop floor efficiency right up to the strategic goals of the corporate office.
Let's break down the four levels of the pyramid, starting from the top, where strategy lives.
Level 1 is the corporate vision or mission. This is the organizational North Star, the long-term goal that defines what success and competitive advantage look like decades down the road.
So for a construction firm, this might be something like to be the industry leader in sustainable, off-site, engineered structures.
Precisely. Moving down to level 2, this focuses on achieving specific critical success factors, CSFs, and core competencies necessary to realize that vision.
And these are measured primarily through high-level external metrics.
Market-related performance, like brand recognition or new contracts won, and financial measures, like overall profitability, it asks, are we winning in the marketplace?
Level 3 acts as the crucial link, translating strategic success into operational guiding forces that management can act upon.
Exactly. These guiding forces are customer satisfaction, increased flexibility in delivery, and high productivity. These are the internal, high-level operational goals that, if met, ensure the achievement of the Level 2 strategies.
You need flexibility, for instance, to quickly pivot your design to meet changing market needs.
You do. And finally, Level 4, the base of the pyramid, is the coalface, the lower-level departmental and site indicators.
The daily operational metrics.
Yes, the process indicators used to monitor the success of those Level 3 driving forces. They include specific measures of quality, like defect rates, delivery, so meeting intermediate milestones, and cycle time, the time required to complete a defined task.
This elegant system ensures that the efficiency of a single crew on site directly supports the corporate vision of being the best.
That's the idea.
These systems provide the structure needed to measure the measurables. But construction is inherently defined by complexity and the unpredictable. Even with the best planning, projects face constant threats and unknowns. We must now turn our attention to Section 6. Managing the specific nature of risk, complexity, uncertainty, and change.
Construction is not like manufacturing where you can control the environment. Projects exist in dynamic, real-world conditions.
And the source material emphasizes that construction is often described as the most complex undertaking in any industry.
It is.
And complexity, in this technical sense, is defined simply as being made up of many interconnecting parts.
Right. And if you consider building a modern airport, thousands of trades, millions of materials, endless regulatory hurdles, strict timelines, all reliant on each other.
Managing this inherent complexity is paramount to project success.
And within that complexity, we often use the words risk and uncertainty interchangeably, but project management demands we draw a sharp line between the two.
This distinction is a vital takeaway for you, the learner. Let's start with risk. What makes it manageable?
Risk refers to an unplanned event where all potential outcomes and their likelihoods are known or statistically predictable to the decision maker. These are the known risks.
So an example would be,
Historical data tells you the exact statistical likelihood of a major hurricane hitting the coast in September, or the known risk of a unionized workforce going on strike during contract negotiations.
and because they are known, they can be accounted for.
Yes. For these known risks, you develop a specific contingency plan and you allocate a financial buffer, contingency reserve, to manage the impact if the risk occurs.
Uncertainty, however, is the terrifying unknown.
That's right. Uncertainty refers to situations where either the potential outcomes or their probabilities or both are unknown or cannot be reliably predicted. These are the unknown risks. The sudden, unexpected discovery of ancient archaeological ruins on the site that halt construction indefinitely. Or a complete unanticipated global supply chain collapse due to a novel pandemic. It is impossible to plan for the specifics.
And we know uncertainty is highest in the early planning phase, before detailed design or specifications lock things down.
Precisely. Uncertainty is multidimensional.
Right.
It could be information related. We don't know the exact subsoil composition, or time-based like future interest rates. It can even be ambition related if the client suddenly wants a major functionality change.
And dealing with this requires fundamentally different strategies than dealing with known risks.
It does.
So, given that dichotomy, let's look at the clear strategies defined in the sources for managing negative risks or threats.
The bad things that might happen. There are 4 core responses for threats. First, avoid. You eliminate the threat entirely by changing the plan, the design, or the scope.
If the risk is using a volatile material, you just substitute it for a safer one.
Simple as that. Second, transfer. Shift the financial or execution impact of the threat to a third party. The classic example here is using insurance against damage or weather delays, or using warranties to shift quality risk to a subcontractor.
Third, mitigate.
This is the most common response. You reduce the likelihood, or failing that, you reduce the impact of the threat occurring. For example, reinforcing a foundation against a statistically known flood risk significantly mitigates that threat.
And fourth, accept.
You take no proactive action unless the risk actually occurs. You acknowledge the risk, maybe a minor price fluctuation, but decide the cost of mitigation outweighs the expected financial benefit, so you simply budget for it happening or not happening.
Conversely, risks can be positive. They can be opportunities, which we must manage proactively to maximize their benefit.
This is so often overlooked, but just as critical as managing threats.
The strategies for opportunities are exploit.
Right. Take decisive action to ensure the opportunity is realized. For example, if you realize a new, faster construction method is possible mid-project, you reorganize to make sure you use it.
Next is enhance.
Increase the likelihood of that opportunity happening. Perhaps investing a small amount in a supplier relationship to ensure they deliver a key component ahead of schedule, thus creating an advantage.
Then share.
Allocate responsibility for the opportunity to a third party who is better positioned to capture it. If an energy efficiency standard suddenly changes, you might partner with an expert firm whose core competence is maximizing those regulatory opportunities.
And finally, accept.
You welcome the opportunity if it arises, but you take no proactive steps to force it to happen. You just note that if the regulatory environment becomes more favorable, you will take advantage of it then.
Now, because construction is so fraught with uncertainty and change during implementation, we already saw that 76% cost overrun, the sources also detail specific contractual interventions.
Right, designed to manage these unknowns right inside the legal framework, which is essential for project finance.
There are 4 methods. First is absorbing.
Since changes are inevitable in complex projects, a contract makes formal provisions like contingencies or allowances, financial and time buffers, built right into the initial contract price and schedule.
Second, dividing or splitting.
When the project is too large or the uncertainty is extremely high, especially in the early phases, The entire project is broken down into smaller, sequential packages or phases. This minimizes the risk and uncertainty contained within any single smaller contractual commitment.
Third, postponing.
When specifications, quantities, or costs cannot be clearly stated up front, maybe due to a unique design element that requires custom fabrication, the contract uses instruments like provisional quantity or provisional sums. This formally defers the final price commitment until more detailed information becomes available.
And fourth, transferring.
This is the method of shifting risk and uncertainty from the project owner to the provider, or vice versa. This is done using integrated contractual approaches like lump sum contracts, where the contractor takes on more price risk, or consolidated systems like design build or build operate transfer, which put all responsibility under one umbrella, consolidating the uncertainty.
These strategies move the industry from a state of denial about complexity and volatility to a state of rigorous discipline management. But to achieve that $1.6 trillion potential, discipline management needs to embrace a radical new direction that fundamentally re-engineers how buildings are delivered.
And that is the focus of our final section, the change agenda.
We've established the depth of the problem. Chronic stagnation driven by fragmentation and a rigid craft culture leading to catastrophic overruns. Now let's talk about the solution.
The one proposed by the most innovative firms in the space. They suggest that acting in 7 specific areas simultaneously could boost productivity by a stunning 50 to 60%.
50 to 60%, that's a huge number.
It is, but the sources go further, suggesting that the ultimate goal for parts of the industry should be a total transformation, moving toward a manufacturing-inspired mass production system.
And that shift could boost productivity up to
An extraordinary tenfold. We are discussing a revolutionary restructuring, not just incremental tweaks.
So the roadmap for this massive shift involves the 7 levers. We start with the macro environment. Lever number 1, reshape regulation.
This is critical because bureaucracy is a massive time sink. Regulation must be re-engineered not to simply enforce minimum standards, but to actively incentivize innovation.
This means increasing transparency and streamlining permitting and approval processes.
And eliminating the bureaucratic bottlenecks that delay projects starts by months or even years unnecessarily.
Lever number 2 tackles the core cultural issue we identified in Section 2. Rewire the contractual framework. We have to eliminate the adversarial, blame-shifting environment.
The contractual focus must shift away from low initial cost alone and toward tendering processes that prioritize best value and, crucially, the past performance of the teams involved.
And adopting collaborative models.
Like integrated project delivery, or IPD. It requires all major parties, client, designer, and contractor, to share risks and rewards, which fundamentally changes incentives and fosters long-term trust.
And critically, rewiring the framework requires sufficient investment in upfront planning, which research has shown to substantially reduce rework and raise productivity later.
You pay a little more for design, but save a massive amount on construction.
Lever 3, rethink design and engineering. This is about making things inherently easier and faster to build.
This means institutionalizing value engineering throughout the design process, constantly asking, is there a cheaper, simpler, or faster way to achieve the required function?
And we need to push for repeatable design elements.
Right, creating a standard design library, especially for core elements like mechanical rooms or bathroom layouts, which don't need highly tailored solutions.
But the single biggest shift here is the industrialization of construction.
By encouraging off-site manufacture and extensive use of precast technology. This means shifting labor out of the unpredictable site environment and into climate-controlled factories, producing modular walls, prefabricated bathroom pods, and pre-stressed concrete beams.
This change minimizes site construction, turning the site into an assembly line where workers are industrial assemblers rather than traditional craftsmen.
Which dramatically improves quality control and reduces weather dependency.
Lever 4, improve procurement and supply chain management. Construction logistics have historically been chaos, materials sitting on site getting damaged or delivered late.
To fix this, organizations need properly skilled central procurement teams capable of negotiating for multiple projects to drive major economies of scale.
But the real power comes from digitizing these complex workflows.
Utilizing platforms like the Internet of Things or IoT sensors and sophisticated enterprise resource planning, ERP software. It enables real-time tracking of materials.
This allows for superior logistics management and finally achieves that long-sought goal of just-in-time delivery.
And that eliminates material waste and reduces the need for costly on-site storage.
The fifth lever focuses directly on the worksite and the execution of the plan. Improve on-site execution. This is where we see immediate, proven performance gains when done right.
4 key operational shifts are necessary here. First, introducing rigorous integrated planning tools like the Last Planner System or LPS.
A last planner system.
The LPS focuses on collaborative weekly work planning, ensuring that tasks are not only planned, but also that all prerequisite inputs, information, materials, labor are ready before the work is committed.
And the results speak for themselves. The sources cite a large-scale oil and gas project that achieved an incredible 70% increase in productivity using LPS principles.
Just by improving the reliability of the workflow. Second, implementing collaborative performance management using agreed-upon key performance indicators KPIs, visible to all teams.
But this has to be complemented by forward-looking metrics, not just historical reporting.
Exactly. Metrics like tasks made ready, or TMR, measuring how prepared the team is for upcoming work and percent plan complete, PPC measuring the reliability of their weekly commitments. They're critical.
They help identify and reduce variance and bottlenecks before they translate into costly delays.
Right, rather than just reporting failure after the fact. Third, applying lean principles ubiquitously to reduce waste and maximize worker capabilities. And fourth, mobilizing projects effectively by ensuring all pre-work is done before the first shovel hits the ground.
Lever 6 is the most transformative. Infuse digital technology, new materials, and advanced automation. This is the key to unlocking that tenfold productivity boost.
This means moving beyond simple 2D blueprints to the universal adoption of 3D building information modeling, or BIM.
BIM.
It creates a sophisticated, data-rich virtual model of the project, allowing all parties to coordinate, detect clashes, and plan construction logistics virtually before any physical work begins.
And we have to move past 3D. We need to utilize advanced analytics, drones for progress monitoring, robotics for repetitive tasks, and crucially, platforms like 5D BIM. What does 5D BIM add to the model?
It integrates time, which is 4D, and cost, which is 5D, directly into the model. This establishes complete transparency in design, costing, and progress visualization. If you change a wall in the 5D model, everyone immediately sees the new schedule implications and the new financial cost.
It eliminates the uncertainty that breeds those adversarial relationships.
It does.
Finally, we address the human factor again with the seventh lever. Reskill the workforce. All this technology is useless if the personnel can't operate it.
Continuous training is absolutely non-negotiable. This isn't just about using the latest digital tools and equipment. It's about fundamentally changing the skill set from traditional craftsmen to highly skilled industrial assemblers, technicians, and digital workflow managers.
And there must be a rigorous focus on knowledge retention and management.
To ensure that institutional learning, which the current temporary team structure destroys, is formally captured and reapplied across subsequent projects. Hashtag outro.
So what does this all mean? Our deep dive has shown that construction is a huge, critical, highly complex industry defined by a deeply entrenched, fragmented craft culture and an adversarial contractual framework.
And this structure actively prevents it from accessing a massive $1.6 trillion potential value pool,
resulting in those staggering 76% cost overruns and 160% time delays.
The failures are not random errors. They are the predictable outcomes of a system that rewards low initial cost over long-term value and lacks fundamental process discipline.
The path forward is clearly laid out in those 7 levers, requiring a radical shift toward process management, standardization, off-site manufacturing, and the infusion of digital technology.
It is a move away from temporary site-based teams and the low-cost competitive tendering trap.
The industry needs to transition to a future where construction is seen as standardized, scalable industrial assembly. A transformation, the source material suggests, could boost productivity by tenfold in certain areas.
And this transition demands that the industry adopt the measurement and management tools, like the balanced scorecard and the performance pyramid, to ensure that it manages effectiveness, not just micro-level efficiency.
But consider this. Given that the industry's current project team responsibility often ends the moment the keys are handed over, they inherently ignore life cycle costing and performance feedback from the finished building in meeting the actual needs of the occupants. You, the learner, should consider what critical information is lost when feedback loops are broken between the designers, the builders, and the people who actually live and work in the building for the next 50 years.
That's a great point.
That lost data, that complete severance of accountability for long-term utility, might be the single biggest cultural barrier preventing the construction sector from achieving sustainable, long-term improvement.
Yeah. An excellent point. The next great frontier in construction isn't just how we build, but how we structure the industry to learn from the world we have already built.
That's all the time we have for this deep dive. We hope you feel thoroughly informed and perhaps slightly hopeful for the future of the built environment. We'll see you next time.